Yeah, so the applications have nothing to do with hearing. What we use the sound for is to move air at very high velocities. So we create like two hurricanes, you can say, in an enclosed system. The sound makes the air move up to, or the particle velocity up to 75 or 90 meters per second. And it switches direction, many times per second. So we have a very oscillating, very fast flow of air.
Thanks for listening to Sprint, the podcast of the Federal Agency for Breakthrough Innovation of Germany. My name is Thomas Ramge, and today we have another episode in English because our guest is Swedish. I look very much forward to talking to Helen Mattsson today. She's the CEO of Infrasonik, a company that uses infrasound to change many things, and we'll hear what those things are. Thank you very much, Helen, for taking the time.
Thank you for inviting me.
Helen, what's infrasound for those who are not physicists among us?
Yes, so infrasound is simply sounds with low frequency, below 20 hertz. So it's lower than what the human ear can perceive. So many companies or technical applications use ultrasound. That's usually what people mix infrasound up with. But that's at the other end of the sound spectra, so to say. So that's very high frequencies. So we work with the very low frequencies, which typically have very long wavelength.
But it's not about hearing, right? I mean, it sounds like it's about the sound, but actually it's more about the wind part of the sound, right?
Yeah, so the applications have nothing to do with hearing. What we use the sound for is to move air at very high velocities. So we create like two hurricanes, you can say, in an enclosed system. The sound makes the air move up to, or the particle velocity up to 75 or 90 meters per second. And it switches direction, many times per second. So we have a very oscillating, very fast flow of air.
Okay.
Which enhances heat transfer.
Okay. So, let's dive into that. So it's not made for the ears. It's made for basically this pressure caused by a very, very strong wind, basically, which is encapsulated in a small space. That's it. I mean, so when you create your strong wind, why you do it? I assume you don't power wind turbines, which obviously might be also interesting, but it's not yours. It's not your use case, right?
There are many different industrial applications. Since it's a long wavelength, it's usually more a good fit with industrial applications. And we work with two main areas. One is cooling, and then it's often steel cooling, so metal processing. When you produce different types of metals, it goes through many processes, which includes heating and cooling and heating and cooling. The thing with our technology is that we can cool much faster than you could do with fans, for instance, because then you blow air on the plate from one way to the other, and it's not an energy efficient way of doing it. So instead, we can use the same air and just bring it forth and back over the plate, cool much more energy efficient and much faster than you can do today without having any contact with the plate other than the air. So that's one application, and it's one area that we have worked with for a long time with some industrial partners. And then the other big area we work with is drying, and mainly of drying of grains and biomass. So quite similar, it's a very energy-intensive process. And today it's required quite a lot of heat to dry. And we do this in a very different way. So we can lower the optimal drying temperature and also reduce the energy needed by fluidizing the grains or the biomass with the sound and kind of mechanically moving some of the moisture from the material.
Okay, yeah, sounds easy to understand. Wind cools. So, what kind of metals are you cooling? Is that sort of steel in these huge steel
yes,
mills?
exactly.
In these huge steel mills? Okay. It's not special metals. Or, okay.
I mean, you can use the technology for replacing cooling beds, for instance. Those typically take up very much space, and the space is expensive, so you could reduce it to 1/3 of the space it takes today. But you can also treat the steel to get some other material properties by cooling fast, which you today do typically with oil or with water. And one of the benefits we have is that we can control the cooling curve, so we can, we can kind of tune the cooling based on where you are in the cooling process.
So in principle, that sounds like a fairly simple technology. I mean, I know that I can sort of cool my tea or my food if I blow on it. How comes that what you are doing is technologically revolutionary in some sense, despite the fact that the basically physical principles are obviously obvious and long time known?
Yeah, I think what's very interesting about it is that no one else is working within this technical field. So I don't really know what reason that is, but Mats, the founder of this company, he kind of realized this, I think it was in the 70s, that, okay, it could be actually a very energy efficient way of moving energy or mass and heat transfer. But then there would be needed some generator that generates these sound pulses. It's basically, that's our product. It's the hardware that generates these pulses, which we call pulsator. And he was looking everywhere to find one, to try to realize some of his ideas, but he couldn't find any infrasound generators. So he started to make one. And this was before internet, so he couldn't just Google or search in that way. He spent a lot of times at libraries reading articles and books and literature, but it was a very novel area, basically. I can't really answer why no one else have done it, but it has definitely for the industries that we show this technology, they are very interested.
So in this case, I understand it was a typical founder need story. I wanted to use it and I don't find it, so I have to build it myself.
Yes, for the core technology, it was like that. But for the application cooling of steel, it was the opposite. So in that case, it came from the R&D manager at Gestamp Hartec. It's part of a very big Spanish company that they asked, could you develop a technology where we use this infrasound to actually cool our plates in a very small space that they had in between a furnace and a press in a press hardening line. So the core technology came from the founder. I want to develop this, and then the application came from the end user.
If you have a look on your website, it's quite impressive how many big names you already have as customers. I mean, in the field you are, I assume obviously the potential customers are in most cases large companies. So how does this sort of collaboration between the Swedish David and all these Goliaths, this industrial Goliaths, how does that pan out? How do you get along together? And obviously I ask because, I mean, as everyone in the field, in the innovation ecosystem field knows, not all the time these collaborations between highly innovative startups like yours and these large companies are as easy. How does it work with Infrasonik?
Yeah, I think we must have been lucky then in that sense. We've had really good cooperations with first Gestamp Hartic and now also SSAB and some other actors. And maybe it's about finding the right person who is also an enthusiast. Of course, the challenge for us has been like the pace. Obviously, we would want everything to work or to develop faster, work quite fast, and they have their internal processes, and it has taken much longer time than we would have wanted, but at the same time, I mean, their perspective is we can definitely understand it, and for them, it's all about reducing technical risks systematically. So it has been very good for us to work with these big companies to also learn how to do that.
Tell us a little bit about the trajectory of your startup. Since when do you exist? How big is the team now? How did you? What's the status about capital, venture capital, and so forth?
Yes, so the company was founded. I think Mats, he started the company in maybe 2010 to just have a frame to develop his ideas within. He developed a barbecue, for instance. So it was kind of like a hobby. And then when when we started this cooperation with Gestamp, that's when I started at Infrasonik as well, 7 years ago. And we have had we usually get to hear that we are different, especially in the funding sense, because we haven't had the need of bringing external capital in. For a long time, we had the cooperation with Gestamp and then with SSAB. So the idea has been to try to manage to develop the company without external resources, basically.
Through cash flow to cash inflow from your customers, right?
Yeah, exactly. So we've been consulting, kind of co-developing the applications. So just to clarify, to make sense of this, our business idea is to sell pulsators, the part that generates the sound, and then the other part of the application, such as the cooler in the example with the infracooler, we will not try to sell that part. So we have been consulting in developing the full system, which we have had some revenue in. And then the last couple of years, we have done some smaller funding rounds with basically just people in the team, our families and consultants that have been working for us, to been able to recruit some more people. But it hasn't been the typical VC journey.
That sounds nice. Well, if it's family, fools, and friends who bring something new into the world, but also the Swedish innovation agency, Vinnova, which we admire a lot here in Germany, also has been involved, right?
Yes, of course. So that has been a critical part of building the company like this. They have really supported us in at different stages of the development, and also the EIP. It's an EU agri fund distributed through Jordbruksverket. They have really funded the application of drying. So we've been successful, and I think the reason why we have been able to receive some of these grants have been due to the novelty of the technology. There's really nothing similar out there. It's a different approach to solve some very known problems.
And is it just public money, or does Vinnova also support you in other ways?
We've been part of their deeptech startup program. So it's kind of similar to this sprint circle training that there have been some lectures and support in other ways. We were also part of Uppsala Innovation Center's accelerator program, I can really recommend to find these types of networks, because it gives a lot of connections and relevant networks. And we have found that many, especially a bit more senior people who maybe are at the end of their careers, they really want to try to help to get in contact with the right people. They usually have really great networks to take part of, and they're willing to share that.
Sweden is a very innovative country. I mean, especially relative to its size, has a lot of innovative output, great startups. I mean, obviously, Spotify only being the tip of the iceberg. What do you Nordics get right about innovation? Yeah,
I think it's part of our culture, maybe, that it's okay to fail. We have a very strong social network, which has always helped individuals, so to say. So you're not dependent on your family or anything. The social network will kind of catch you. So maybe that helps to try their innovations.
Tell us a little bit about yourself. You're not an engineer, or half an engineer, if I've seen that right on LinkedIn. So you've worked as a consultant.
No, I'm an engineer. It was a joke when I studied that they called us the PowerPoint engineers, because it's like a program mixed with economics and business. But it's normal engineering. And I think every day here, I don't think anyone who's not an engineer would enjoy being here, because it's a lot of physics on the board every day and a lot of math, which is very fun. And it's the reason, I think, why I have stayed here. I started working as a management consultant after finishing my studies in Lund.
So starting off with the PowerPoint aspect of your engineering career.
Exactly. Starting off with PowerPoint, and then I moved to the more, where I was looking for a place where I felt like what I did had some meaning, and then the innovation part of it's kind of makes it always fun to go to work, that we're developing something new almost every day. Something new changes or improves, or it's a very interesting dynamic in workplace.
What's your personal motivation? What gets you out of bed every morning? And what keeps you awake in the nights?
No, I'm not awake in the night, unless sometimes my kids wake me up. But other than that, I'm a very good sleeper. But every morning when I go to work, I think it's being part of developing something completely new. And there are always challenges that come up that we need to solve. But it's a very creative and problem-solving environment. And everyone who works here are also, very intelligent and creative people. So,
how did you hook up with Sprint, and what do you do with us?
It's a good question. We have a woman in our board, Carola Pustali, and she is also in the board of another company who work with biochar. And they were somehow connected to Sprint, and she really recommended us to reach out to Sprint as well. So now we have a validation contract with Sprint since October till May, and it aims to validate some. I mean, there are more potential areas than drying and cooling. So it's kind of to explore where it could make the most positive impact. So
what is it? What else to come? Or can you or can't you talk about it? I mean, you just said that you don't have any competitors anyway, so I think you can talk openly over that the best is still to come.
Yeah, I mean, it's some of the parts within the frame of this contract has been still cooling and also drying, but drying different parts. Like mussels, and there are some potential in food processing and grass seeds and stuff like that. But the two newer areas that we're exploring has been actually making biochar as well. Because the first area that Mats, the founder, worked with was to remove soot from big boilers. And he's also made a barbecue, so we've always known that it has a big impact on like combustion processes. And we wanted to, evaluate whether we could also improve pyrolysis processes with this Infrasound. Because what it does is that it evens out the temperature zones, for instance. So we built a smaller test rig and made some tests, and it seems that we can get some more yield from the process, which will be interesting to develop more. We need to basically make something bigger to be able to make more tests. And then the other area, which is quite new, and we have a thesis student now from KTH who is working with that, is sieving. So sieving moraine, I think that's the English word. It's like stones. You need to separate different particles so you can use them for different things. And it can also be used in like metal recycling and so. So today the challenge is that you can't sieve when it has too much water content, and also when it's difficult to separate particles that are too small. And it's a very old way of doing it. It's like a mechanical weight that shakes a sieve, basically.
Yeah, and you'll do this with wind or enhanced by wind?
I wouldn't call it wind,
okay.
but
infrasound. Okay.
Yes,
got it.
Yes, exactly. So the sound can help fluidizing the material, and it has in the small tests we have made. It really helps to both separate and also being able to sieve it with higher moisture. And now we will make a full-size test in the spring.
Okay. Sorry, I'm still hooked up on your metaphor of the hurricane. The hurricane in the chamber you are creating. But exactly. Okay, got it. Okay, we'll never use the word wind in this context anymore. Call it infrasound. So, what are the next steps? Let's have a peek in the future. In an optimistic scenario, what will you have achieved in, let's say, 1 year, in 3 years, and 10 years from now?
Like now we're at the stage where we really try to move from just developing phase to start commercializing and selling the products in different applications. So for the drying area, it's which is maybe shortest time to market from where we are now. I hope within a year we have started both to sell some references of dryers, but also established some partnership with like industrial manufacturer of drying equipment, so that we can scale it and reach more end customers. And I hope to also have some customer within food processing, because I think it seems like the demand for something that can dry waste products from the food industry is really demanded. And within 5 or 10 years, I hope it has changed the normal standard, for how industries dries. And within cooling, I think it will take a little bit longer time. But of course, within 5 or maybe even 10 years, it's the same goal to have this partnership with OEM to be able to scale it. Because as long as we sell straight to the end customer, it will take a very long time to establish new customers and new projects. So we want, of course, the technology to have big impact, and then we need to find ways to scale it.
What are the biggest challenges you're facing in order to become standard practice?
One challenge has been the tough requirements from these types of customers. Like they demand very many working hours without any service. And of course, any stops are very costly. So it's a challenge to meet the industry's requirement of a working product, basically. And we have made one very important step by making a long-term test with one customer. So our product was just running at their site for 5,000 working hours. So that was an important step, but I think we're still not quite there. We need to, adopt some other parts. And then the real challenge is, it will probably show when we have more units out in the reality, in the real world. That's maybe when the problems start showing up. So right now, it's getting it out there in the real world, and then as it's out there, it will be probably taking care of technical challenges.
And competition-wise, you've stretched that you're basically quite alone out there in the desert. Do you see other companies, startups, sort of also at some point at least attacking in the field?
I wouldn't call it attacking, actually. I think it could even be beneficial to have more actors, because then it would be more accepted. It would to develop faster. And I think it sounds maybe easy, and when you look at the hardware, it looks quite easy, but there are so many design elements, and part of it, you need to have all the dimensions right. It's kind of like a music instrument. And it's more know-how to it than it seems. And I think maybe really big companies, we've had discussions with SSAB, for instance, what their interest would be. And to them, it's so much knowledge. So for them to build up that themselves, it's more costful than cooperating with us. And for very, very small companies, it's maybe it's a big technical barrier to get all the knowledge compared to what Mats has developed over all of these years. So we really have that benefit of the know-how. So maybe some other mid-sized companies will start competing, but I think that it's enough. There are enough applications and markets to explore, so there is room for more.
So is your founder, Mats, now using the technology for grilling?
Every day.
Every day?
Yeah, I'm not kidding.
Not sure. Unless he's only grilling vegetables, not sure if that's so sustainable.
That's true. At least you use less coal when you barbecue, because
but if he's grilling beef, that doesn't sound like a very.
Not. He's grilling everything.
Okay. The last question is one that I asked to all my guests. What radical innovation, what radical technological breakthrough do you wish to see in the world in the year 2050? And it should not have to do with infrasound.
I've seen that there is some development with AI that enables humans to speak to animals. At least that's how I interpret it. Maybe they're not all the way there, but it's kind of coming. But what I would want to do would be to communicate with plants.
With plants?
With plants, yeah.
Oh. What kind of conversation will that be?
I have no idea. I will see in 2050.
Okay. Excellent. Very interesting idea. Never had that. Helen, thank you so much for being on our pod.
Thank you for having me.
And to you, all your dear listeners, thank you very much for your time and attention. If you like our podcast, please leave us a rating in your podcast app. The Sprint Podcast is produced by Max Zerner. Thanks, Max, as always. And in 2 weeks from now, we're going to be out with the next episode. Until then, as always, stay curious.